I made a test for this week using two full spectrum LED, 50 watts each. This is the arrangement of the test. I used our 8.7 centimeter wide heatsink with a length of 20 centimeters. The LEDs were equally spaced apart, and the location of the measurements was here at this point and at this point, just inside the base of the heatsink. The way I do this is that I drill in a perpendicular fashion with a very small drill bit the side of the heatsink so that I can put the thermocouple inside. This is the image of the test of the experimental arrangement. This is that 20 CFM fan, which is used for active cooling. Otherwise, the temperature will get really hot and the LEDs will fail. The thermocouple can be seen here, and it goes inside the base of the heatsink. This photo shows the experimental arrangement in operation. This is a thermal image of the arrangement while in operation. The average temperature of the light emitting surface is about 121 degrees centigrade according to the thermal camera. However, the measurements made by the thermal camera are not that accurate. So for considering that, I made a measurement of 2 points using the thermal camera, one in the light emitting surface in the hottest spot, and another one in the point where the thermocouple measure was made. As you can see here, the hottest temperature was 142 degrees centigrade measured by the camera, and at the point of the thermocouple was 63.5 degrees centigrade. Now I will show you the data for the thermocouple. The thermocouple measured at this same point, at point A, where the camera measured 63.5, it measured 55.3. The measurement in the other zone was 56.9, almost the same. The difference between the temperature measured from the thermal camera and the one measured by the thermocouple is 8.2 degrees centigrade. Using this as an estimation of the difference in the light emitting surface, the temperature at the light emitting surface would be closer to 134 degrees centigrade. However, this kind of approximation should be used with caution, as the emission of the two surfaces can be different. However, it works as a first approximation. 134 degrees centigrade is almost in the maximum limit recommended by some manufacturers like Cree, which establishes that the maximum temperature at the light emitting surface should be 135 degrees centigrade. So in conclusion, this arrangement using two 250 watt LED full spectrum and a 20 CFM fan that I have used in all the other experiments of active cooling, with the fins pointing upward, is the maximum limit one can use for putting two LEDs in this arrangement. If one would want to have a lower temperature, the CFM of the fan should be greater. However, I wouldn't recommend or using one LED per fan. And this analysis is very useful because a lot of clients use these this kind of LEDs for their applications. And that's it for this week.